So yes, let's get started. Hi everyone. Thank you so much for joining us for our Code with Ken on Introduction to AWS DeepRacer today. I am Aditya Obray, a third year student at Amity Noida. I am a Microsoft Learn student ambassador and I have been working as a community intern at Progate for the last few months. So before we just rush into the session, I'd like to tell you all a bit about Progate. Progate is an online coding education platform for beginners. It is the largest such platform in Japan. We currently have over 1.5 million users worldwide, and we are aiming to become the best possible way to start learning to code as well as become independent coders. Our vision essentially is to empower everyone and help them affect changes that they want in their lives by and open new doors for them through the world of programming. In fact, those are the lines on which this company was actually started. Our founder Masa, he'd been studying in Japan, and he found that there was no such platform where they could actually easily learn how to develop websites and etc. And that's why he and some of his friends they worked on it and created this platform. And since then, it has grown on to become what it is today. So our mission is to be the gate to the exciting world of programming and be the path to become an independent coder. So yeah, let's get started. And today we have with us Mr. Archishman Zanazaney. Archishman is a Microsoft Learn student ambassador as well as an AWS Educate student ambassador. And thank you so much for joining us, Archishman. We're very happy to have you today.
Yeah, thanks a lot, Aditya. It's amazing to be here. It feels amazing. I'm really looking forward to today's session on AWS DeepRacer. So let's get started. I guess I'll just start sharing my screen. If you guys have any doubts or something, we will have a Q&A session at the end. So just a request to keep your mics on mute while I'm presenting. So the session will go like, there's a complete learning session on reinforcement learning that we'll follow and how that will be, how that is implemented in the AWS DeepRacer. So you'll learn about reinforcement learning and the AWS DeepRacer. Apart from that, we will also just run through the code and we'll walk through the console of AWS DeepRacer, and that should be it. Uh, because it's a cloud account, so we didn't really want any hassle regarding logging in and all of that. So hands-on part is completely optional. If you want to try it along with me, you are free to do so. Otherwise, you can always try it out later and reach out to me if you have any doubts. So let's get started. I'll switch off my video for now and start sharing my screen.
Yeah, have you shared?
Yeah, just 1 second.
Okay, sure.
Yeah, I hope you guys can see the screen now.
I think it's still loading here, so just give it a second. Yeah, perfect.
Okay, cool. Just 1 second. Yeah, cool. Amazing. So, welcome everyone. Thank you all for joining today's session. So, let's get started with AWS DeepRacer and what exactly it has to offer. I'm Archishman Zanazaney, and I'll be your instructor for today's session. So, we'll just start off with what exactly will we be learning today. We'll we'll learn about machine learning on AWS and why exactly is that being. Why are we learning about machine learning and why AWS in the first place? Secondly, the working of the AWS DeepRacer. What exactly is AWS DeepRacer and how is reinforcement learning really driving it? Then we'll move on to reinforcement learning and understand the concepts of reinforcement learning, followed by what are rewards in reinforcement learning and what exactly, what role do rewards play in reinforcement learning. So we'll go through all of that today. This is a beginner friendly session, so nothing like you will have to be very good at math or very good at coding or a tech geek or something like that. It's just open to anyone who's just willing to learn some new technical stuff. So I'll just walk you through the mission of AWS. Our mission at AWS is basically to empower every developer and student and to put machine learning in the hands of every developer. So, and we keep updating and upgrading a lot of our services time and again. For example, in 2018 alone, there were about 200 features and services that were introduced. And every reInvent is, by the way, a conference conducted by AWS, and that's an annual conference. And at every reInvent, we launch a new product at least. So I guess in 2018, DeepRacer was launched, and in 2019, it was Deep Composer. So let's move right ahead to machine learning on AWS. There are tens of thousands of customers who are using AWS, developers or students like us, and industry grade applications as well. So in the picture that you're seeing as of now, these are just some of the companies that are using the machine learning platform by AWS. Some of them to mention are Netflix, Formula One, NASA, and Snapchat. So you might know NASA's recommendation
That's
system.
actually crazy. Wow.
Yeah.
It's a huge list.
Yeah, and these are just, I guess, some of them. So all of you might know Netflix's recommendation system. That is completely deployed on Amazon SageMaker, right? So that is
Wow.
precisely how it's done. Yeah, and also, I guess, yeah, so this stat is also that 85% of TensorFlow projects in the cloud are trained on AWS. That is precisely why we'll be learning about AWS today, because this is, again, an industry grade technology that you'll be learning about. These are some of the AI services that are offered by AWS. Let's start off with the basics, as in frameworks and infrastructure that is being offered. TensorFlow, MXNet, and PyTorch are some of the frameworks that are supported. Some of the interfaces are Keras, scikit-learn, and yeah, these are just some of them that I've mentioned here. You can see all of them in this particular slide. The ML service that is, used widely in the industry is Amazon SageMaker. You can also code your model, machine learning model from scratch in this ML service, or you can just get your model, you can get your code from your local system and just deploy it on SageMaker. Moving on to AI services. Okay, I'll just talk about just one of them for now, so that you get a brief description of how these are different than the ML services. In ML services, you have to code, or you have to get your code, and then you use it for your own applications. For AI services, what happens is it's already been coded, and you just have to implement it in your application or in your company, wherever it is needed, right? So what Amazon Poly does is basically you write whatever. Suppose you want something that is written, that is printed, and you want it to be read out. That is what Amazon Poly does. You just type whatever you want to be spoken. You want Amazon Poly to speak, and it comes out as an audio. So that's as simple as it is, right? So you don't have to code anything. You can just use it, AI as a service. Moving on to how exactly can I get started? Amazon Poly, Amazon recognition, all of that is okay. But how will I get started in machine learning with AWS, right? So that is a question that all of us have while we're starting. So let's talk about the three basic products that they have to offer, using which we can start learning ML. AWS Deep Lens is, you can see these three in the photo. AWS Deep Lens is mainly used for computer vision and deep learning applications. So I'll just see, there's just something, I guess someone has asked in the chat. Okay, my voice is echoing, is it? Is someone's mic on? That might be the case, if it is echoing.
Just check once.
Yeah, just give me 1 second. Is it fine now? Or is it still echoing?
Yeah, I think it's all right, because everyone else knew.
Okay, that's cool. Cool, thanks a lot. So
yeah, hi. If you
sorry.
think it's echoing, can you just already, I was just speaking to the participant. If you think it's echoing, can you just leave and rejoin once? I think that might fix the issue.
Yeah, that might. Anyway, thanks for letting me know. So let's move on ahead. AWS Deep Lens is basically focused on classification applications. So suppose I have a set of images, I want to classify them into if it's a dog image or if it's a cat image, right? So that can be done using AWS Deep Lens, and that is mainly used to learn computer vision and deep learning. Second comes our AWS DeepRacer, the reason why all of us are here to learn reinforcement learning, right? So I'll tell you how exactly it uses reinforcement learning and how it is applied in autonomous vehicles. AWS Deep Composer uses generative AI. That's one of the most advanced topics of artificial intelligence. So I won't really dive too much in depth about that. But something that you'll have to know, I mean, basic is that generative AI, as the name suggests, it creates something new, right? I mean, it has the ability to create something new. The other machine learning algorithms don't really have that ability. It's either just guessing, probability, or just classification problems. They don't really generate something new. So this creative generative application is one of the biggest reasons why generative AI is catching up a lot. So yeah, that's about it, and that's how we'll get started today. AWS DeepRacer. Yeah, so what exactly is AWS DeepRacer? If you have to buy the model, it's also available on Amazon. But I mean, for this session, nothing is needed. So if you are buying the model, that model will be 1/18th the size of the actual race car, and it is powered by reinforcement learning. So obviously, it's an autonomous car, right? It's an autonomous vehicle that you'll be driving on the virtual circuit on the AWS console. So how's that running? How's that working, right? That uses reinforcement learning. Now I've been using reinforcement learning, this term, quite a lot of times. So what exactly is that, right? Reinforcement learning, we'll go through a lot of that again in this presentation, but just to give a brief overview about that, reinforcement learning is just I mean, the agent learns a lot by gaining a lot of experience, and it's something like training your dog. So once while you're training your dog, you give it a reward, or you give it a treat if it does something good, and if it does something bad, you obviously don't punish it, but you don't give a treat, right? So eventually the dog will learn that what actions are giving it treats, and that is how it'll get trained eventually, right? So reinforcement learning is somewhat like that. The car is on the track, you let it explore the track a lot, it will crash, it will move off the track, and all of that, but eventually it's been given rewards, right? So if it moves off the track, it's being penalized. That is, you give it -1 point probably, or probably 0.001 point. And if it's on the track, if it's moving on pretty well, then you give it +2 points. So eventually the car will learn that it has to be on the track. And that is how reinforcement learning works. So let's move right ahead to the next slide. And these are the various machine learning techniques, right? So there's artificial intelligence. Machine learning is a subset of artificial intelligence. And then comes supervised, unsupervised, and reinforcement learning patterns. Just to put it into simple words, I would define machine learning as something like, giving the ability of taking a particular decision to machines. So machine learning is basically the machine's ability to take a particular decision. Now, what that decision is, that depends on the application. So supervised, unsupervised, and reinforcement learning are the different types of machine learning algorithms. And so let's go through each one of them. In supervised learning, the data has to be labeled, right? Like I said, the cat and dog image classification, that is a very good that is a very good example of supervised learning, because in supervised learning, what happens is you give the outputs and the inputs both to the model, and then it learns on its own on how to match what are the characteristics that are matching to the input and output. So when you give two new samples to it, it automatically matches them, because it has gone through so many samples already, that okay, this is cat, this is dog, this is cat, this is dog. And if you give after hundreds of such image training sessions, if you give two images, it will be able to distinguish if it is a dog or a cat. But it has to be labeled, right? I'm telling it that okay, this image is that of a cat, this image is that of a dog. Now you find out if, like, I mean, these are the inputs that we are giving, and then that is how it works. So that is how we are training the model, right? In unsupervised learning, what happens is there's no labels given. So it's something like the generative AI that I mentioned, that uses unsupervised learning. So you're just given the input, and the algorithm learns on itself the underlying patterns of the input, and that is how it goes, right? So one of the best examples of that is probably fraud credit card transactions. So you're just giving inputs as to what transactions are being done by the credit card, and like where is it being spent and all of that. So if there's an anomaly, if like there's a certain pattern that is being followed in a particular number of trials, and suddenly you see that okay, there's a lot of transaction done for this particular thing, that is something, there's something wrong with that. So that is machine learning under, I mean, unsupervised learning, right? So that is one type of machine learning algorithm. Talking about reinforcement learning, like I spoke about the dog, and I mean, how you train your dog, it's something like that. So you give your dog a treat every time it does something good, and you won't really punish it, but you won't give a treat to your dog every time it does something bad. So eventually the dog will learn the actions that are giving it treats. So it'll start performing more of those actions as well. The terminologies that are required to learn in reinforcement learning are the agent, the actions, the state, the environment, and we'll go through all of that in detail in this session. So let's move right ahead and see what exactly, I mean, is reinforcement learning in AWS DeepRacer. Like I already mentioned, the agent in our case is the DeepRacer car itself, right? So, I mean, what is the environment that you think? So, let me tell you one thing: agent and and environment can be something like the car is the agent, and environment is the track. So, it has to explore the track. It will keep moving on in the track, right? And once it's moving on the track, if it goes off the track, and if it is on the track, any which way, it will get a reward, but reward can be like, if it moves off the track, the reward can be 0.001, and if it is on the track moving on the center line, then the reward can be probably 2. So you're getting the understanding, right? The reward can, like, if it's moving on the track, then it'll get a reward of 2. If it's moving off the track, then a reward of probably 0.001. So where is it getting a higher reward? 2. So it'll try on moving on the center line the next time, right? So in that way, reinforcement learning is driving the deep racer in a literal way. Like it's mentioned here, it puts the auto in autonomous for deep racer. And yeah, models learn by receiving rewards for it. A reward is basically a feedback, right? The agent gets feedback every time it does something, it takes an action. So that is how it works. So this is what the console will look like, AWS DeepRacer console. And we will go through all of that later on in this session. I'll walk you through the entire console, how you can build your own model and all of that. So for now, let's just move ahead and learn more about reinforcement learning. So like we've already discussed quite a lot of times now, that reinforcement learning is basically a type of machine learning. And it's just a machine learning technique wherein the agent is put in an environment, it explores a lot, and then exploits that knowledge to take more actions that are, that will give it a lot of rewards. So this exploration exploitation is used, I mean, is extensively used in the case of deep racer, right? Um, what you'll have to know is the agent is first placed on the track, that is deep racer is on the track. For now, let's just forget about the other terminologies or anything. Just know that, okay, the car is on the track, right? The deep racer, and that is on the track, and that is the agent. While it is moving, where is it moving exactly? It's moving in the environment, right? That is on the track. So that is exactly how it will learn. It will tend to explore more on the track, and it will see, which by taking what action am I getting and more and more rewards. So the entire goal is to maximize the rewards that are being, the total reward that the agent gets, and that is precisely how the deep racer will complete complete the race. So we'll learn more about the agent now. The agent in our case is the replacer car, like I've told. So what are the actions it can take? The agent can either steer left or right, or it can increase or decrease the speed, right? So this is what the agent does. What is the environment in our case? The environment in our case is the track, right? For now, just keep these two things in mind. There has to be an agent. What is the agent? The agent is the replacer car. There has to be an environment. The environment in our case is the track, right? So it basically describes what the agent can do. Like the environment. So basically, the entire state space where in exactly the deep racer car can go, or till where the rewards are counted. Like suppose it goes completely off the track, then the rewards are obviously not counted, right? The reward is only till, if it is going that off the track, then you get a negative reward, or probably 0.001 reward, which is a very less reward. And if you're on the track, you get a higher reward. So it is an environment that describes, where the deep racer car can go and where exactly can it get rewards and all of that. So it tends to explore a lot in the beginning, and then later on, once it has explored, it'll tend to exploit that knowledge so that next time when it goes, it knows what I have to do. Um, so that knowledge completely transforms, like, okay, if I do this thing, I might get this reward. If I do this, I might get this punishment. So it goes from somewhat, it goes from that thinking as to, should I do this, to I really want to do this. That is, I will get this reward if I do this thing. And that thing in our case is the track. Like it has to follow the track and complete the race. That is our end goal, right? So that is eventually how, after a lot of iterations, the deep racer will know as to how exactly, it will get rewards. The entire goal, I mean, the entire um, main topic of reinforcement learning is rewards. We'll go through the reward functions and all of that just in a few slides, and you'll just know more about that as to, why rewards play such an important role in reinforcement learning. So I hope you've understood that part of it till now. State is, in our case, is just a snapshot of the environment. And how can the snapshot be taken? It can be taken from the front camera that is located at the front of the deep racer. So that is precisely how a snapshot is taken, and that is a state, right? These terminologies might not seem very important as of now, but they will help you grasp the topic better later on. So yeah, let's just go right ahead to the next topic, and that's okay. These are just actions, like I've already mentioned. The only thing that it can do is, turn right, turn left, or just increase or decrease the speed. So now we've come to rewards, right? Um, so this is when we'll actually see the rewards, and this is the reward function. Uh, you don't have to understand the whole concept as of now. I hope you've just understood that, okay, how does reinforcement learning work? It is completely based on rewards. How does the reward system work? I gave you the dog example. I'll just reiterate it if someone has joined just now and you just want to learn it again. So okay, I'll just give a different example then. All of you have faced power outages on the internet and all of that. You know the dinosaur game on the web browser. So what exactly happens in the, okay, I'm not sure if anyone knows that, but if at all, suppose, okay, just keep in mind that, okay, there's a robot, and the robot has to, just dodge through the obstacles that are coming on its way. So how does it do that, right? Suppose I want to automate the complete game of robot, and I want to just, I want to win the game just by using reinforcement learning. How do I do that? Um, for that, I'll have to figure out a way to find out, at what particular instant of time and at what particular point um, should the robot take a jump to jump over the obstacle. And if I somehow find an algorithm to do that, then my work is very simple, right? I'll just write an algorithm, I'll write a code, and then that's done. So that is what is the case in our case. That's what we are following, but we are also giving it rewards, right? So that is precisely how it works. So every time it does something good, in our case, the good is following the track and not moving off the track, taking a turn when it has to take a left turn, and then just following the track, right? So if you're following the track, if you're on the track, you're getting a reward. If you're off the track, you don't get a reward. So that is how it works. And you'll just see the code over here on the left-hand side. I hope this is visible. So what are the two parameters we're keeping in mind? The track width and the distance from center, right? So just to, make it much more simpler, we'll go to the next slide. Yeah, now you'll understand the code much better. So our deep racer is on the track, the track is divided into 25%, 50%, and complete track, right? So just note the first divide the complete width of the track into half. That is this dotted line, and on each side that is divided into 25% and 50%. So suppose this deep racer is going on the center line, it keeps on getting a +1, +1, +1 reward. If it moves like a bit to the right hand side, it gets a plus 0.5 reward. If it moves even more right to this second red line, then it gets a plus 0.1 reward. And then if it moves again, if it tries to go off the track, that is this final red line, then it gets 10 power minus 3, that is 0.001 reward. So if you can see, the more it tries to deviate from the center, the lesser rewards it keeps on getting. So suppose imagine yourself that okay, you are the deep racer and you are on the track, you keep on getting rewards. If you're moving on the center line, if you move up, if you deviate left and right, you get lesser rewards. Eventually you'll learn, right? Okay, if I move on this particular line, I will get a reward. So that is how the deep racer eventually learns. It has to go training for a lot of times. The camera has to see, okay, where exactly do I have to go, where exactly do I have to um, take a turn and all of that. But eventually, I guess after probably 200 times or something, you'll have to train the model, and then it will finally be able to complete the track, or get a good standing in the leagues, in the deep racer league. So that is precisely what this code does. Like you can see, marker 1 is equal to 0.1 times track width, marker 2 is equal to 0.25 times track width, and marker 3 is 0.5 times track width. And then you have it's just a simple if condition that you've done before, like just before attending this session, you might have done a Python module, and just it's an if else condition. So if distance from center is lesser than or equal to marker 1, what is marker 1? 0.1 times track width. Now let's go to the marker 1 is 0.1 times track width. 10%, 25%, 50%. So that is precisely how it works, right? So, and that is what this code does as well. So I guess you understood that part of it. The more it deviates, the lesser rewards it gets. And over a period of time, over a period of trials of the model, it will eventually learn as to which path to follow to get maximum rewards. Yeah, does anyone have to speak anything? Okay, I'll take that as a no then. Cool. So let's move ahead to see it in a much more better way. I guess you can understand it in a much more better fashion in this way. So we have divided the whole track into a grid, and these are the cells, right? So suppose the car is going, with the car starting from here. Let's move here. So the car goes from here to this. It follows this line, right? The total reward that it gets for this is 2.2. Whereas if you think about it, if it goes say from here, the next two cells and then right, the next two cells and then right and then left and something like that, it keeps on taking turns. It will get, much more, it'll be rewarded much more, right? So that is essentially how it learns to, follow the right path. So in our case, the episode is, so I'll just explain what an episode is. An episode is something basically I've started the race from a particular point of time. I'll move back one slide. It is starting from here, this position, and it just moves off the track, so it stops there. So the start point and stop point is, the stop point might not be completing the race. It might just be moving off the track. So this complete, starting and stopping this whole thing is called an episode, right? So once it started and when it stops, the episode gets completed. So that thing is called an episode. Remembering that these terminologies are quite helpful, but I won't really say they're very important. The idea is to understand what is it doing, and how does it have to go the right way. Let's go back. So here, if you see, probably you can add another parameter. What parameters have we used here? The track width and the distance from center, right? So these are the only two parameters, but we can also add another parameter called speed. that it can increase it if it goes below a certain speed, it should not be rewarded or something like that, right? So that it can keep on going at a particular high speed that you want, or you can even set a penalty if it exceeds a particular speed limit. So that can also be done. Iteration is one of the most important topics in any machine learning algorithm. Suppose I'm writing a code, I have to deploy it on a particular endpoint. The endpoint in our case can be deploying it on the DeepRacer. So once I've deployed it, I have to train that model a lot of times. It has to go a lot of iterations for it to achieve even something close to completing the race. So I mean, because this is not being done by humans, there has to be a lot of training done to the machine learning algorithms, and that has to be done so that the model actually understands what actions it has to take so that it reaches so that it completes the race in our case, or it reaches convergence. What is convergence? I'll let you know in some time. But so that is essentially why iteration is necessary, right? Because you have to train it a lot of times, to make it understand as to what actions it has to take. The complete, it's the same strategy: exploration and exploitation. The model has to explore a lot so that it can exploit a lot from the given data. Yeah, we're back to exploration and exploitation. Now, please note, if you see this grid diagram again, you can see that the car has reached the final stage, the final checkpoint. If you compare it with the previous images, it's at now in this image, it's in the front spot, the starting point, and then it goes here, it crashes, it sees that it has got 2.2 reward points. The next, it gets a little more reward points. We again started, and now it figures out a way that okay, I have to go here, I have to go here. So in that case, like this is the way how it trains itself to reach, to completely get the highest of total reward possible. So like I said, exploration is one of the most important topics in reinforcement learning. The model has to explore a lot of data so that it can exploit a lot. Because in reinforcement learning, we are not giving it data, right? In unsupervised learning, at least we are giving the data. It's not like, we have been completely not giving data. In reinforcement learning, it gathers the data on its own and it learns on its own. So that is how reinforcement learning works. And as you can see, you don't have to worry too much about, how this graph is done and all. So we saw, right? As of now, we know what a reward is, and we know what an episode is. An episode is basically the whole time frame and the whole experience that it has gained from a starting point to an ending point. The end point can be that it has crashed on to the sides, or it can also complete the race. So that is one episode. So here you can see that for these many episodes, the total rewards have gone up, and it has also gone a bit down. So the last reward that it got it's here. Let's see exploitation. Now you can see the total reward has gone up, right? And also it has kind of optimized its distance, and how it can get more rewards. So this is how it learns. This is how the RL model learns on its own: exploration and exploitation. I just have a chat here. I guess someone is. So reinforcement learning, there is no need of a controller. I didn't really get your question. Okay, I'm guessing that we don't have to do anything if that is what you're asking. Okay, cool. So yeah, we don't really have to do anything. The only thing that we have to do is writing the code for the model, right? That is the most important thing. So the whole machine learning depends on that. You don't have to do anything. You're automating stuff. So in reinforcement learning, you have to write the code that is this code. I'll just go back. Yeah. So this code that you can see on the left-hand side, that we have to write. But in case of AWS DeepRacer, that has also been written in the console. If you want a higher rank in the DeepRacer league, then you can choose to, make amendments to that code as per your wish. You can add some parameters. Like I said, the speed is another parameter that you can add. So that is another parameter. And there are other parameters as well that you can think of. And just to optimize your model and make it reach the final stage much more faster. So yeah, so just moving ahead with the exploration part. This is the exploration graph. So, and this is the exploitation part. You can completely see that the rewards have gone up. The total reward for the last episode has gone up then as compared to this one. So that is exactly how the model works. I hope you can get a much more better picture of it now as compared to what we had started with earlier. Moving ahead, the parameters of the reward function, like we just discussed, there are a lot of parameters, right? I can even control the steering angle, that okay, it shouldn't turn beyond the steering shouldn't turn beyond this particular angle. And where exactly is the car facing, that's called the heading of the car, the track width. That we use the track width and the distance from center option. So that can be it. And so there are quite a lot of uh, parameters that you can keep in mind. This is the okay, this green part that you can see, that's the track. And if you can see the circle marked over here, there's an x coordinate mark, there's a y coordinate mark, and that is the position of the track. I mean, that is the position of the vehicle on the track. So you can also determine your position, right? This is different, this position is perfectly fine. But if it comes somewhere here, we have to say that, okay, no, this is not done. It can't go there. Also, this, like suppose, let's say this arrow mark, right? So the car obviously can't go there. If it goes there, then it has gone off the track. You can give another, lesser reward for, at that point in time. So these are the different things that you can use for your reward function, the code that we saw there. Uh, I'll just talk a little more about waypoints and what these are. Talking about waypoints, these are basically different points on the center line that you can see at the center of the track. And how do they help the DeepRacer? So you guys must have seen ants. Whenever ants are moving together, they move so closely, right? They move quite closely, but they don't collide on each other. I mean, they don't touch each other. There's a particular path that they follow. So that is precisely how it works. I mean, the first few ants have started going on, then the later on ants start finding out that, okay, this is the path to follow, this is the particular point where I'll have to focus on, and then a particular path is defined. So that is how waypoints help. I've just got another chat. Let's see. Do we have prior knowledge about the track? We sense it in real time. Yeah, you do have prior knowledge. The DeepRacer doesn't, right? The DeepRacer doesn't have prior knowledge. You will have to see, I mean, you can see the track before. The DeepRacer will be trained on the track as well, which is why it is reinforcement learning, right? So suppose I'm giving the track already, I'm loading the image of the track and all the snapshots of the track that the DeepRacer will see, then it becomes supervised learning, right? Reinforcement learning is learning on its own. So that is how it is learning. The DeepRacer cannot see the track. You can see the track on the virtual console, and that is how it works. So I hope that answered your question. We'll go ahead to the next slides. Cool. So it's lab time. Let's go ahead and see what the AWS console has to offer. Is it possible for the DeepRacer to navigate its way through varied terrains? That depends actually, because it's quite difficult to train that way. It has to go through a lot of training. It has to explore a lot so that it can exploit that data later on. Like, I mean, I'm just using the same terminology so you can understand and apply that in a better way. It can go through varied terrains if it is on the track. I mean, because I mean the body looks quite rigid. The DeepRacer's body is quite rigid. I'll be showing that to you on the console. So it shouldn't really have that much of a problem. But usually it's meant for track races and all of that. So that is precisely how it works. I'll just stop my screen sharing for now, and I'll walk you through the AWS console and how you can build a model if you have to, right? So I'll just give me 1 second. Cool. Just 1 minute. Meanwhile, if you guys have any questions, just feel free to drop them in the chat, or yeah. Cool. So I'll just start sharing my screen. Just give me 1 minute. Yeah. Can you guys see my screen? Okay, I have another question. So it needs to have experience of moving over a particular terrain before it actually understands the features. Yeah, exactly. Because you're not providing the data beforehand, right? It has to explore on its own. It has to collect that data. Then it will train itself that okay, if I go here, I'm not being rewarded. If I go on this particular track, I'll be rewarded. No, exactly. So you don't have to use external control when it's going on a unexpected area, unknown area that it has never gone to before. That is how we are placing the AWS deep racer in the track for the first time, right? When you're placing the deep racer on the track for the first time, it doesn't know, it doesn't know about that track. It's seeing that for the first time. So it is bound to go off the track or just hit a wall or something like that. But that is how it will be trained. Once it goes off the track, it will know that okay, it's not being rewarded for this, but it will know, it will understand the point at which it was rewarded once it was on the track. So it'll, the next time you put it on the track, it'll probably take 2 steps on the track and then probably move and crash. Then it'll, I mean, that sort of cycle has to happen thousands of times. Only then will it understand that okay, it has to be on the track. Another question: why do we use reinforcement learning and why not supervised or unsupervised learning for deep racer? Unsupervised or supervised learning. Okay, first of all, for unsupervised learning and supervised learning, you have to have data given beforehand. So in this case, we are not giving the data beforehand. Imagine, yeah, exactly. Yeah, we don't have the input, right? So imagine a Tesla car, imagine a real autonomous car, right? You can't give all the inputs of all the roads at the first time to the car. It will obviously not know, and that's next to impossible also. So it has to learn on its own to figure out a way. As okay, if it's on the road, it will get rewards. If it's off the road, it will, penalized for it or something like that. And eventually, that's why we are using reinforcement learning. Cool. So I hope you guys can see the screen. It's the AWS console. Can you see it? Cool, amazing. All right. So this is what the AWS console looks like. This is, I'm just using the AWS account. This is a cloud management console. And you can see the services here. So these services are being offered by Amazon Web Services. I'll go through DeepRacer for now. So this is what we saw in the slide as well, right? That, the console will look something like this. There are DeepRacer leagues. You can evaluate your model, order, and AWS DeepRacer over here. So yeah, that is about it. Let's go ahead and see. So if you want to submit your model to a virtual race online, you're free to do so for the AWS Virtual Circuit and AWS Summit Online. For now, we'll see your models and your garage. Okay, I'll just walk you through your garage first. So this is what you can see, right? This is what AWS DeepRacer looks like in a true sense. If you have to buy it, it will look something like this. and you're free to customize it and add your own sensors and all to it. Like some of the most advanced deep racers use lidar sensors. Those detect, if it has to collide with another car, it will detect that beforehand and that it will notify. So I'll click on build new vehicle and you can see. So if I click on this sensor is being added here. Otherwise, there's a camera. The benefits of using the camera and all are given. Model specifications. Camera, you can also add 2 cameras, right? So I'll click next for now. And these are the actions. Like I said, you can set your deep racer's granularity as to where should it steer, left or right, or how much left, and maximum degrees it can turn. So maximum steering angle, as you can see, is set to 30 degrees for now, the highlighted part, and the range is 1 to 30. So it can't turn like beyond 30. So that is one of the cases. Also, please note, so if I just scroll, you can see that the degrees are given in minus also at times. So what is minus? If it takes a right turn, if the steering is towards the right, then it's negative angle. If it's towards the left, then it's a positive angle. Or if you want to fine tune it even more, then there is steering angle granularity here. Maximum speed, like I said, this is one of the parameters. You can set your maximum speed of the deep racer, that it shouldn't exceed or something like that. There's speed granularity also over here. So 1, 2, 3, and yeah, that can be it. So you can customize your deep racer completely in here. I'll just move on to next. And yeah, you should name your deep racer and color orange. I'll just choose black for now, and then done, right? So I already have my model made up here. I'll show that. So guys, one thing that you'll have to keep in mind is that, it takes about 1 hour to train your model on the console. Please note that this is a cloud console, right? So it's not using your own system's memory. Yeah. So just 1 second. Yeah, I guess I can. Yeah, I guess I'm audible now. So yeah, so in cloud, what exactly happens is, the resources of some other computer or server are being used, and not your computer's resources, right? So your computer might have, say, 4 GB RAM, like my laptop has 4 GB RAM, but I'm running it on the cloud, so it's completely fine. I can run it on a high computing computer as well, on if I'm using AWS cloud. So, and that itself takes like 1 hour to train or something. It takes 1 hour to train your model after specifying everything. So it was obviously not feasible to do that part now. So I have trained my model, but I'll just walk you through, how you can. Okay, so this is my model's evaluation and all of that. I won't really go through that. I'll just show you how to create a model first. So you have the option of importing your model, or let's just create a model, right? So these are the things that we have already seen. The agent takes an action in the environment, then it gets a reward for it. Then based on that, again, an action is taken, then it's in a particular state, right? What is the state we just saw? A snapshot of the environment at a particular point of time is the state. So it's in a particular state. So it can see that. Yeah, so let's just go. Cool. Yeah, so first you'll have to specify your model name. I'll just type in DeepRacer demo. Right? This is optional if you want to just give a brief description of your training job, like what exactly are you training in the model or something like that. You can have that as well. These are the different tracing tracks that you can choose from. I'll choose Reinvent 2018 for now. So there are different types of tracks given. We'll click on next. So these are different type of races that you can take part in, right? There's object avoidance, there's head-to-head racing, there's time trial. We'll see time trial for now. Object avoidance is, like the name suggests, the main objective is to complete the race, as well as dodge the objects that come in the way. Head-to-head racing can be, you'll be on a virtual circuit, you'll be racing with a bot. If you're racing on an actual circuit at any of the summits or conferences, you'll be racing with other deep racer cars. So again, object avoidance and time trial both will come into picture. Time trial is basically how fast you complete your uh, race. So clicking next. Now we've come on. Now we've come down to the reward function. So we just saw, right? Uh, in this reward function, I'll just highlight the two parameters we are using is track width and distance from center. So our whole objective of giving this reward function is that reward it every time it is close to the center of the track, or just if it's on the track, and just give it 0.001 here. This reward if it's likely crashed or close to off the track. So that is when you'll give it 0.001 reward, and 0.1 reward when the distance from the center is less than 0.5, less than 0.25, and if it's less than 0.1, then a complete 1 reward is given. So exactly what we saw in the presentation, and this is basically the reward function for that. The various reward functions available. This is for time trial. Then it's for time trial, stay inside two borders. What are we using here? All wheels are on the track. This is also another parameter, that all of your wheels, or all the wheels of your deep racer car should be on the track. That is again one of the parameters. Like suppose one of the wheels goes off the track, then a lesser reward is being given, like 10 power minus 3. So something like that. Prevent zigzag. There's another code for that. Prevent the deep racer car from going zigzag. Again, this is a reward function. The parameters might be different, but entirely the idea is the same. So this, I'm just showing this to you so that you get a brief idea of what exactly is a reward function, what parameters can be used, what exactly is happening in the code. We are using a simpler code in this case to make you more understand, to make it much more understandable to everyone. Because simple if-else statements are used, assignment statements are used, and they're just parameters that are being used. So that is how it works in reinforcement learning. So this is the code that we're talking about. Talking about hyperparameters, these are really important, right? So what exactly are hyperparameters? Parameters, we know, we are specifying them in the code, and they can, they are defined to give us rewards or punishments or penalties every time we are going off the track or something like that. Hyperparameters can be fine-tuned by you, the human. So these are specified by us, and they're not hard-coded in the code. So let's just go through all of them. What is gradient descent batch size? Now the default value in this case is 64, but the more the value technically, the more training data it is going through. So gradient descent batch size basically means how many training data, like in an episode you have that one experience, so that is one part of the training data. So you will have many episodes like that, right? Many experiences. So like how many episodes like that, right? So that is in a sense gradient descent batch size, that how many training data, how many times the training data is going through the whole cycle. Epochs is basically how many times the model is being retrained again. Like one complete training session of the model is called one epoch. So that many number of epochs. So we are having 10 epochs over here. Learning rate is, okay, so this is very important, right? Learning rate, entropy, and loss type. You can see the loss type here. These might seem quite overwhelming at first, but let me tell you, okay, so suppose I have coded the code for machine learning algorithm for DeepRacer, but there is also a very high chance that it is not going to be perfect, right? No machine learning code is perfect, and nothing really as such can be perfect if it's going via the machine learning, because it's not done by a human, and our ideology is that of humans, so we expect it to be perfect according to human self, which is obviously not the case. So what exactly, so it can be close to the ideal goal but not completely exactly the ideal goal itself, right? So there's always this difference of the expected and the ideal one. So that difference is called loss, right? And So we have different types of losses here: mean square error and Huber loss. Huber loss is mainly used for convergence. Okay, so I told you guys that I'll tell you about convergence. To put it in a simpler way, it's just the exploration and exploitation part. The model explores a lot of things on the environment, on the track, and then exploits that data to fine tune itself and to get more and more rewards. So what happens is, the more and more rewards it keeps on getting, the model keeps on reaching the ideal stage, and it finally reaches a convergence value wherein that is the ideal stage. And if you train it many number of times after that particular point of time, it might start giving a lot of errors. So at that point, we have to train the model to reach. So in case we are using Huber loss in this case, because we have to uh, get the model to attain convergence. Suppose you have your model trained perfectly all right, and it's working amazing. You've trained it for 1 hour. It's working fine. It's just that you want to increase your speed or something like that. Then you can use the mean square error loss. Then that is advisable. For the first time training, use Huber loss. It's very good for convergence and all of that. So that is what it is. Coming back to learning rate is basically how many number of times the weights are adjusted in the loss function. Okay, I know none of this, I mean, it's not, I've not mentioned this before, but I'll just mention it now. What exactly is loss? We discussed that now, right? So a function, I mean, just like the reward function, there is a loss function too, and that is basically what defines the loss, right? So our complete ideology should be to minimize the loss as much as we can. And how can we do that? So we've done one iteration of the learning. The model has undergone one or few iterations of the learning. Then what happens is it updates something, right? It updates some values and then again retrains. So what is it updating? Those are called weights. Those can be certain parameters. In our case, that okay, it's updating few of the parameters and then again retraining. Probably it'll get a better output, and the loss is lesser now. So how many number of times it is it is updating the weights, that is given by the learning rate. Entropy is the randomness. So I'll tell you, entropy randomness again, how random can it be, how random can the model be, right? So the in exploring the environment, that is essentially what it means, and that is what we will be seeing. I'll just show you my model that I had trained, and you'll see how random it is and all of that. So this is the randomness, just a quotient for that part. Discount factor is basically how far should I see to get the rewards, right? A discount factor of 0.1 maybe that okay, a discount factor of 0 might be that I will consider only this stage, that is 0th stage is discount. So my current type, my current point, I'll just consider the reward for that, and then I'll take my decision based on that. A discount factor of 0.1 means I'll consider this one and the next, and then I'll get the total reward, and then I'll see which action to take. A discount factor of 0.999 means the next 1,000 steps I will get the total, I will see what my total reward is for the next 1,000 steps, and based on that I'll take my next step. So that is what discount factor means. Loss type we have already seen. Number of experience episodes between each policy updating and iteration. So that is again the same thing, right? That we saw, similar to learning rate. So, and stop condition is very important, guys. Here we have mentioned 60 minutes because 60 minutes is the ideal thing, and that is how it's. That is when the model usually tends to learn and reach convergence. If you're using default values, if you're not using default values, it will not reach any the convergence in that particular point of time. So stop conditions are basically defined because we are using cloud models. So initially you might use the free tier, but eventually you'll have to pay for it, right? If you exceed a particular limit. So we are just keeping a time limit here so that if suppose if I train for 11 hours or something, then I'll have to pay to AWS, right? Because I'm using their services. But if I'm using in the limited time and given specification, then I don't have to worry about that part. So it just This is just setting, so I mean, you can call that as an alarm, or just a stopper that the training stops on its own after 60 minutes. And even if the model is not has not reached convergence, even then the training will stop. This is an option to submit automatically to the DeepRacer League, and the pricing is given here. So please go through that if at all you're interested in a DeepRacer and all of that, using DeepRacer on the console. This is what it is: 10 free hours of training and evaluation. So I guess that's about it. Once you click on create model, your model will be created. I'll just go back to your models and I'll see the model that I had created. Yeah, so this one I had created earlier. I'll just click on that to show you. Right, so in my case, the training is complete. If you can see, oh, okay, the simulation video is not available. Just refresh it if possible. Cool. So in this case, as you can see, the average rewards and average percentage completion and all of that, training and evaluation, all of that is there, right? Green graph indicates the average reward for a particular iteration. So if you can see here, I don't know how many, I guess around 300 iterations or so must have been complete. So the model has undergone iterations for 300 times, and that is how it trains, right? Like I said, it takes a lot of time to train the model. And if you can see, earlier for 50 iterations, the rewards were only 21.15. Eventually the model learns, okay, it has got, see, it was 21.15, then it goes to 22, 32.55, 32.7, and then eventually it goes on increasing based on its experiences. So that is what it looks like. I'll just start evaluating. I'll evaluate on the same track, same start evaluation. Okay, so evaluation will take about 10 minutes or so. I'm not really sure if that is suitable, if that's advice that you'll have to wait for 10 minutes or something, because I mean, you won't see anything as such really. You'll just see a video of my DeepRacer training here. I'm not sure why that's not available. Okay, that's not available during evaluation. Cool. So here you'll see our trials, how many trials has it undergone, then time for each trial. So every time trial basically means episodes, right? In this case. So every time it goes off the track, it'll be mentioned here. And for how long, the status, trial was, all of that. And all of our hyperparameters are mentioned here, guys, the ones that we chose. The framework that we have chosen, all of that is mentioned here. The reward function you can see here. So all of that, action space, if it takes minus 30 degrees, the speed should be 0.33 meter per second. All of that is seen. And that is exactly how you'll see. You have an option to submit it to the virtual race and your model is ready to race. Cool. So I guess we are done with our part about this thing. I'll just stop sharing my screen. Yeah, so I guess we are done. Do any of you have any doubts or anything as such? Aditya, anything from your side? I'd like to
I think
show
it's
some.
been great. Yeah, definitely.
I'd like to show a trailer for this year's DeepRacer League, so you guys can probably get more excited about DeepRacer. Just give me 1 second. All right, so I'll just start sharing my screen. Can you guys see my screen now, Aditya?
Yeah, it's visible.
These are 1/18th scale RC cars that are fully autonomous thanks to reinforcement learning. Developers will compete for the fastest lap of the day.
Sup guys, Daniel Ricciardo, 7-time Formula 1 winner, first time AWS DeepRacer. I think you're faster than me.
Tatiana Calderon, Formula 1 test driver, machine learning beginner. Wanna race?
Take your best shot at some of the world's best professional drivers. Follow their machine learning journey during the month of May.
Yeah, I guess we are done. Over to Aditya. Over to you.
All right. Thank you. So yeah, we did it. Awesome job. Thanks to everyone for staying through this session. And we really hope to keep seeing you in future events.